All right, looks like we're all set. Thanks. Good afternoon, everybody. Thank you for being here this late in the day and for making the treacherous journey across 7th Avenue. Thank you for coming. I am David Smith. I am a member of the Cloud Developer Advocates team at Microsoft, and you can see many of my fellow team members over there on the right. The font is quite small, as you can tell, but if you want to check us all out, you can have a look at this first link right there. But something you might notice if you do go ahead and take a look at that link is that many of us in this team work in open source technologies, whether that be Linux or Kubernetes or Docker or you name the project, we're all quite involved in that. And part of our mission is to talk to folks like your kind selves about how to use open source technologies in the Microsoft ecosystem. And in fact, that is going to be the topic of my talk today, which is about using open source tools for data science and for machine learning within the Azure environment. That's a particular area of specialty for me because I'm a data scientist. I've been working with data for well beyond 20 years at this point, as you might be able to guess from my gray hair. My tool of choice for doing data science and machine learning is the R programming language. Just with a quick show of hands, who here is familiar with R? And oh, it's actually more than I expected. I was not expecting a big R familiar crowd with here. So for those that are familiar, you will see a few examples using R. For those that are not familiar with R, I'll be using other tools like Python and TensorFlow and Spark in the examples today. But as I said, my tool of choice is R, and I've been working in the R project for a long time. I'm a member of the R Consortium board, and I also write about R and lots of other aspects of machine learning and data science at the Revolutions blog, and you can have a look at what I write about at the link right there. You can also follow me on Twitter at RevoDavid, and I tweet quite regularly about things that I see in the machine learning and data science world. So moving on. This particular talk is not going to be very surprising, especially if you're already using open source tools to do machine learning and data science. And in fact, that is my intent with this talk, is to be as unsurprising as I can. Because what I want to show you is that you've already got your own workflow working with open source tools. You have the editor you like, you have the engines you like, you have the ways you like to do graphics integrated with other systems. What I want to show you and demonstrate to you in this talk today is you can carry over all those same experiences and skills and bring them into the Azure environment with very little changes, except being able to make use of much greater processing power, the availability of things like powerful GPUs, the ability to create powerful clusters, so you can take the data science and machine learning methods you develop in your local environment and scale them up into big data sets and big compute jobs within Azure. And I'll show you how to do that and try to make it as easy as I can, as I possibly can. So in the talk today, I'm going to focus primarily on open source tools that you're already familiar with. I'm actively going to avoid here a lot of the Microsoft specific stuff that you might be seeing in the other tools, and try and couch this in things that you might be familiar with and comfortable with. Me personally, I come from a Linux background, so I'm particularly happy now that I can use Bash within my Windows environment, and I'll show you how I do that and how you can do the same thing as well. And then use Bash within Windows or any other Unix or Linux-like environment to interface with Azure using the Azure command line interface. Then I'm going to dive in to some fairly detailed discussions of the deep learning virtual machine. This is a virtual machine image that we provide on Azure, which has a whole bunch of tools already set up for you, ready to go. And that's available both on Ubuntu and Windows, but I'll be using the Ubuntu image in the session today. We'll also take a little look at Jupyter Notebooks. I'm sure many of you are familiar with using Jupyter Notebooks, and I'll show you how to do the same kind of thing in the Azure environment. And I'll also show you one, this one is a little bit more Microsoft specific, the Azure notebooks that are available within the Azure service, which is a great way to share notebooks you've developed. Then I'm going to switch tracks a little bit and start having a look at GPU-enabled compute environments, and specifically give you a quick demo of using TensorFlow to take a Python script that you've written in your own environment to do a TensorFlow computation, and how easily you can transition that over to a batch cluster, in fact, running GPUs to scale up that analysis. Likewise, I'm going to show you another instance of scaling, in this case rather to big compute, but rather to big data, by scaling your analytics over into a Spark cluster, and how you can, in this case, run R within a Spark cluster to do machine learning on data that lives in that cluster. I'll be popping up various links during the talk. Don't panic if you don't catch them. I will pop them up again at the end, so you can grab that with your camera, and these slides will become available later on. I also will point out this is quite a code-heavy talk. I did make the fonts as big as I can, but it only goes so far. So if you don't want to be able to read the code, you might consider moving a little bit closer, because some of the fonts do get a bit small. With my glasses, I kind of need to do that myself. All right, so first of all, let's dive into how you can interact with the resources available to you in the Azure cloud. Now, when I first started working at Microsoft a few years ago, this was basically the only option for interfacing with Azure. It's a web-based portal. You can pointy and clicky all your way around to set up, let's say, virtual machines, for instance. Just again, with a show of hands, we had a small group, so we can make this fairly interactive. Anybody use the Azure portal so far? About half the people. I've got quite a few people. So you're familiar with this idea of filling out a bunch of fields in a form to generate. It's a really good way of discovering services. It's great for one-offs. It's not so great when you need to do this thing over and over again, because it's quite difficult to repeat that process. One of the things that I recommend you check out if you haven't yet done so is that little prompt at the very top of the Azure portal there. That's a way to get an Azure Cloud Shell, which will basically give you a command line. It can be a Windows command, it can be PowerShell, it can be Bash, where you can do command line commands to do those kinds of things again. The way I actually like to do that is directly within my desktop environment. You can install the Azure command line interface in your local shell. As I mentioned earlier on, I prefer Bash. And so in a minute, I'm going to show you how I can deploy a virtual machine using these series of command line incantations, and then just wait for it to run and then launch into that machine again. This has been really good for me when I do big projects I need to share with other people. They need to replicate the processes that I've used to spin up services in the cloud. It's also great for demos. As you can see in a minute, I can just run a line of code and get things done. And it's available on all the different platforms, and importantly, it's also available and consistent whether you do it in Windows or Mac or any of the various Linux environments, or within the Windows subsystem for Linux, which is actually what I'm going to use in just a moment. You can find lots of information about the Azure CLI at this link, which I'll provide to you at the end of the talk. I want to show you a little bit about my desktop environments that I tend to go for. I'm using here a Surface Book 2. It was given to me when I joined Microsoft a few years ago. Prior to that, I typically used Macs. It took me a little while to get used to it, but now I actually really quite like it. And one of the reasons I do quite like it is because of Visual Studio Code. I think we all get very attached to our editors. I was a big Emacs guy for a long, long time. In fact, I think if you have a look at the contributors file in Emacs, you'll probably still find my name there. But I have transitioned to code in the last couple of years because it has that same feel to me of Emacs, of being a really, really rich editor with lots of extensibility. But most importantly to me, it's cross-platform. So I get the same experience whether I do it on Windows or Mac or within a Linux environment. And there's a really, really great team that works on this. So if you just, again, show of hands, we can do this with a small group. Who's used Visual Studio Code? Yeah, a few people haven't. For those people that haven't checked it out, one thing to remember is Visual Studio Code is an entirely different thing from Visual Studio. They're kind of designed to have similar kinds of interfaces, but Visual Studio Code is the completely open source variant and has lots of extensions and plugins created by the community for you to use. But I'll be using it at quite a few bits in my demo, so I'll just quickly point out some of the sort of interface layers. We've got source code editor there, syntax highlighting. In this case, I'm looking at a Python file. You can have an embedded terminal, and this is where I'll be running several of my scripts to actually interface with the Azure CLI. And you've got various tools available to you over on the left-hand side, depending on what kind of plugins you've installed into Visual Studio Code. One thing I'm going to mention but not use in my demo is something down on the corner there called the AI Explorer. And one thing you might want to check out is something called Visual Studio Tools for AI, for Visual Studio, or if you use Visual Studio Code, it's called Visual Studio Code Tools for AI. It provides a lot of streamlined interfaces, for example, to take a script that you're developing in Visual Studio, automatically move it over into a virtual machine that's running in Azure, do the computations there, return the results back locally, so you don't have to faff around with a lot of the file moving and data moving side of things. It's really useful. I'm just not going to show it to you here because I did want to show you a process that works in any environment. But if you do want to check out Visual Studio Code Tools for AI, there's a great talk coming up on Wednesday by Chris Lauren in the Expo Hall. So I do recommend you check that out. So the first thing I wanted to do is show you, give you a little tour of doing data science with the Azure Data Science Virtual Machine. Now, what is the Data Science Virtual Machine? It's basically an image that a team of data scientists working at Microsoft have put together with lots and lots of data science and machine learning tools already installed. Many of them are open source. There are a few proprietary tools available to use in there as well, and I'll mention those briefly. One of the really nice things about the the Data Science Virtual Machine is that everything just works, and it just works together. If you've ever fallen into Python package hell and installed one framework and it conflicts with another framework and all those kinds of things, the really nice thing about the Data Science Virtual Machine is everything there and works together straight out of the box. It is available in both the Windows flavor, but I will be using the Ubuntu flavor for this particular session here today. One of the nice things about the Data Science Virtual Machine is that even though it does include some proprietary components, you don't actually get charged for them. All you actually pay for is the underlying virtual machine infrastructure rate, and I'll talk a little bit about that in a second. So just pro tip, if you want to do something with SQL Server, or you want to do something with Microsoft R, or some of those other tools there, you can essentially get free developer access to all those tools via the Data Science Virtual Machine, but I won't be talking about those in detail today. But there's a couple of links there where you can find more info about the Data Science VM, but let me zoom into that little chart there just so you can see some of the things that are available to you within the Data Science VM. All the languages that you might be familiar with for doing machine learning and data science are available to you. The two big ones, of course, R and Python are available as complete builds there, plus many of the common packages and libraries that you use with them already come pre-installed. A few other interesting things too. There's, of course, C#. Julia, if you haven't checked out Julia, really interesting up-and-coming language for machine learning, already installed in that environment as well. When it comes to your developer tools, Visual Studio Code is available in there, PyCharm is in there, RStudio is in there, all the IDEs and tools you use for developing applications in these languages already available right there. Lots of higher-level data science tools like Weka and Drill, allowing you to explore data within those environments, which could be stored within just about any kind of data set. If you want to play around with loading data into MySQL, or you want to play around with loading data into Spark or Hadoop, all of those instances come available to you direct within the Data Science Virtual Machine. And plus, the modern machine learning and AI frameworks, TensorFlow, CNTK, MXNet, PyTorch, all those are built right in to the Data Science Virtual Machine, and also with lots of sample data sets and tutorials. It's a really great place to learn those new environments if that's something you're thinking about doing as well. The other nice thing about the Data Science Virtual Machine is that it's designed to work with GPU workloads. So if you're working with TensorFlow and want to speed up the training of models using its GPU acceleration and GPU distribution, that all happens out of the box. And in fact, the versions of TensorFlow, MXNet, and PyTorch, and other frameworks that are installed on the Data Science Virtual Machine are already pre-configured to use GPUs. There's actually nothing you need to do. It happens automatically when you run it on those GPU-enabled virtual machines. So that's in Azure, the NC class virtual machines. which are attached to NVIDIA, Tesla GPU cards of various strengths and flavors, as you can see here. You also might find, as you're looking through the Azure Marketplace, something called the Deep Learning Virtual Machine. Don't get confused, that's exactly the same as the data science virtual machine. The only difference is it's constrained to working on these NC class virtual machines and includes some extra data sets and tutorials to get you started with working with these AI frameworks. So the whole idea, and this is the process I'm going to show you in just a second, is to do iterative development first on your own environment and then with the data science virtual machine to scale up to these bigger workloads and then scale out to multi-user applications. So you can either connect to a data science virtual machine or do this on your own environment, use your standard development tools, do your debugging, do that iterative process of trying out different models and getting that model to improve and get better as quickly as you can. And then when you want to scale that up to production level data sets, put it on a larger virtual machine with more memory and faster CPUs, or for those AI workloads, put it on a virtual machine with GPUs to speed things up even further for those applications that are enabled to it. And then when you want to scale that out to applications that have many, many endpoints, perhaps applications, AI applications that are living at the back of a mobile application or a highly trafficked web-based application, you can then deploy them to multi-node clusters, into Spark-based clusters, or even scale them out into VM scale sets so they'll automatically scale to accommodate the workload that comes to the applications that your developers build around your data science workloads. Just a couple of recommendations when you're looking at the various types of VM instances, virtual machine instances that are available to use with the data science virtual machine. And just really, there's many, many options that are listing here. One of the most common ones that I use. The most basic one that I tend to jump in on is this DS3 V2 instance with 4 CPUs or 4 virtual CPUs. It's got a decent amount of RAM. The processing is decent. It's really good for sort of active development. In my demos today for the data science virtual machine, I'll be using DS4 V2, which doubles the amount of CPUs, so I can accommodate lots of simultaneous data applications there. If you really want performance though, have a look at the A8 V2 virtual machine. That is a compute optimized virtual machine with faster processing capabilities. Little less memory than those general purpose CPUs, but that hasn't been a problem for me when I want to go there and get the speed. When you're going to the GPU-enabled virtual machine instances, again, lots of options to you there, but the two that I tend to gravitate towards are the standard NC6. That tends to be one that has the most availability as well, so taking out the TensorFlow workloads, and then there's a higher version of that, the ND6S, with double the RAM and a much faster instance of the GPU. I just put some representative costs over here on the right. The marketing people really want me to emphasize that these are not quotes. It depends on which region you're using it in, and these things change over time. But I just really put them there so you can compare the relative prices mainly of the different types of VM options there. One thing I'll warn you against, by the way, is there is a free option that's available to developers in Azure, and that's the standard B1S instances. Just don't even try those with these data science workloads. They just don't have enough RAM capacity mainly to do the kinds of things we want to do. So just save yourself the pain and don't even try it. Once you've launched one of the data science virtual machines, there's lots of ways you can connect to it. And this tends to be the big problem in a sense until you figure things out. It's like, how do you use your IDE? How do you use your graphical interfaces if you're using GUI type applications in these environments? When it's Windows is actually the easiest. If you're familiar with using Windows, you can just use remote desktop. Azure makes it really easy. There's a file you can save on your desktop, double click it, up pops a window, which is basically the same as your desktop, and you can just use it like it was any other machine. But like I said, I tend not to do that. I tend to use the Linux type ones, and there's various options available to you there. Of course, for a command line interface, we can just SSH over to the remote server and log in and connect to it that way. Just a little tip, I only recently discovered SSH copy ID, like in the last couple of months, and I was so angry at myself for the years, literal years I had spent manually cutting and pasting keys over to remote servers until I discovered this. Like, why did nobody tell me about this before? So I'm sharing that with you now. Or if you like to use X Windows, you can use the X2Go client to either get an entire X Windows interface or even individual applications. And I'll show you a quick demo of that, but I tend not to use that too much myself. The main things that I use when I interface into these virtual machines is the application-specific interfaces, mainly Jupyter Hub for Python and TensorFlow type things. And when I'm working in R, I can interface into RStudio Server. And this gives me a really, really nice, rich interface that's running in my local browser. So it's nice and responsive. It's not laggy when the internet's a bit crappy, but it's giving me all the power of the computations that are happening on the remote desktop. And I'll show you how to do both of those right now. So let me drop into a demo here. I'm going to move out to my browser. Right now I'm at portal.azure.com, so this is just the main user interface that you're probably familiar with. The only thing I really wanted to show you here is that I already used that script I showed you earlier on to launch a data science virtual machine. And you can see it's running on the standard DS4. It's 8 virtual CPUs and 28 gigs of RAM. And I also want to grab this IP address because I want to show you how I SSH into things. So let's go to Ubuntu. Oops, if I can type. So this is the Windows subsystem for Linux. If you haven't tried it out, it is super easy. You just basically install Ubuntu from the Windows Store. It looks like an app, but it's actually an entire Linux environment sitting within Windows and works exactly like Linux. So right now I have Bash, and what I can do is SSH over to my thing. My username there is David SMI. Oops, why isn't my right click working? Let's try copying that again. There we go. And as you can see, I've already set up my keys, so I can log in. And now I just have the standard Bash interface over in the remote machine. As you can see, I can't type today. All right, and let's actually run htop, another handy utility, so I can have a look at what's actually running on this machine right now. It's pretty quiet, but you can see that it does have the 28 gigs of RAM available to me and 8 CPUs, which are mostly idle. So let's see what we can actually do with those CPUs at this point. I mentioned you can use X Windows to connect. There's a nice open source client available for Windows to do that, and it's called X2Go. I've already set up the connection with the IP address, and I've already shared my SSH keys, so I can just log directly into the X2Go client at this point. It's making the connections. And in a minute, it'll pop up a window with the default Ubuntu interface ready for me right there. Let's make this a little bit bigger so we can see that. And I know those fonts are quite small there, but I just really wanted to show you, if you are playing around with this, pre-installed into the data science virtual machine is an applications menu where you can go through and see the various things available to you for development. For example, Python, Julia I mentioned in there. This is how you launch PyCharm or RStudio or Weka. Lots of interesting ways to explore the data science virtual machine capabilities through that interface. But personally, as I mentioned, this is something I don't use very often. But if you like working in that, I just want to show you how that works. Probably more relevant to me, though, is going back to my browser. I can log into Jupyter Lab. So let's have a look what's happening here up here first of all. What I have logged into via my local browser is port 9999 at the IP address of this remote server that's running in Azure, and that is running Jupyter Hub for me. The default installation on the data science virtual machine has a whole bunch of pre-installed tutorials, and I'll run through a couple of these in a moment. But if you have your own IPython notebook that you've either developed locally and moved over to the data science virtual machine, or you have developed within the data science virtual machine, you'd access it in this exactly the same way. Lots of interesting things available to play around within here, by the way. There are examples using PyTorch, examples using CNTK. There's a really good tutorial on Julia here. Again, I recommend checking that out if you haven't seen Julia before. But just for those of you that might not be familiar with Jupyter notebooks, I can jump into this intro to Jupyter one, for example. Oh, I did two of those. There we go. And one thing I can do is select the cell, press Control-Enter, and you can see Python dynamically is running that code and then returning the results back in to the IPython notebook. And I can run that particular cell as many times as I want, and because I'm getting random numbers every time I'm getting a little chart. And this is a great way for me to develop code that I'm going to share with others. I do this in R more often than in Python, but it's if I want to put together a document that includes code and output that I want to share with others, it's a nice little tool to do that. All right. I mentioned earlier on, too, that all the packages that you need, or libraries, in this case for Python, you need are already pre-installed on the data science virtual machine. So if you have a script that uses pandas, for example, so in this case to import some data, this is the famous iris dataset imported from a website, and then text frame describe from pandas to have a look at the summary statistics for that. All of that is all built into the data science virtual machine. You don't need to go ahead and do that yourself. So that's IPython notebooks. The other interface I wanted to show you for the data science virtual machine is RStudio. Oops, it looks like I've been logged out. Let me log myself back in again. And let's try and stay signed in. Good, I got my password right. And I don't want to save that password. If you're familiar with RStudio, you've probably used it directly in your local environment as an application. This is RStudio Server, which is exactly the same. And it's surprising how much the same it is to an app. But it's actually running just here in my browser. But the experience is really just entirely the same as that. With the one exception, and this is a really handy exception, is that if I quit my browser, close my laptop, come back to this later on, everything is as I left it when I went away. So it's actually a really convenient way for actually keeping your work persistent by working with it in the data science virtual machine, as opposed onto your local laptop when you restart it, everything goes away typically. By the way, this is just a nice little example of doing the birthday calculation. Any statisticians in the audience, this will be very familiar with to you from your stats courses, being able to calculate for the number of people in a given room, what are the chances that two of us share the same birthday? There's probably 18 people here in this room, and we can calculate it using a simulation, using this function here in R. And again, this computation is, the interface is happening in my browser, but that computation just happened over in the data science virtual machine in Azure. And with this 18 people here in the room, there's about a 35% chance that two of us share the same birthday. You can calculate this really easy using statistical theory, unless you take into account February 29th, then it becomes a lot trickier. So the way I actually did this calculation is to do a simulation of 100,000 rooms with n number of people in it. And then for each of those 100,000 rooms, I simulate 18 birthdays and then check, are there any duplicates in those 18 birthdays? If yes, we'll return 1. If not, return 0. Average over those 100,000 simulations, and that gives me an estimate of the probability. Actually, turns out it works pretty well. And I did it as a simulation to demonstrate that it's a nice thing to use with a multi-core virtual machine, because I can parallelize this simulation over a room of size 1, a room of size 2, a room of size 3, and so on, to get a sense of how that probability changes over the number of people in the room. And here, I don't want to go into the details here, but I'm using a library that's available in R called doMC, which lets me take code that I write in R and automatically parallelize iterations of a loop simultaneously across the cores of a machine. So if I go back to Ubuntu here and look at htop, you can see up here, all of my 4 cores are being maxed out as R is running one of those 100 simulations on each of those cores and then collecting the results back into the local R environment. So that should be finished in just a moment, which is a good chance for me to take a glass of water. While it's doing that, anybody got a guess for how many people need to be in a room before there's a 50-50 chance that some of us share the same birthday? Yeah, remember this problem from statistics? So this is the 100 simulations I just ran by dividing them across my 8 cores. If you look at the 50% mark, how many people in the room does it take before there's a 50-50 chance of us sharing the same birthday, or 2 of us sharing the same birthday? It's about 23 people. So if you're in a room of 22 other people, 50-50 chance somebody in that room shares a birthday with someone else. Little stats lesson there for you. All right, so that was an example of using the data science virtual machine, getting access to the various tools within it, using various interfaces, the shell, Jupyter Lab, and RStudio. So let's have a look at some other ways we can do machine learning in Azure. Oh, one other thing I wanted to mention, by the way, is you saw me using a Jupyter Notebook over there. If you wanted to share that Jupyter Notebook with somebody, you could give them access to that data science virtual machine. But if you want to share it with the wide world, something you might want to check is notebooks.azure.com, where you can upload your IPython notebooks running R or Python or lots of other things, and then share them to the world. I use this a lot when I give public labs. I did one a little while ago down in San Francisco, implementing the not hot dog application from Silicon Valley. So I can take a photo and it'll tell me if it's a hot dog or not a hot dog using cognitive services. Not the topic of this talk, but if you want to check it out, it is available in Azure Notebooks at that link right there. And it's a great way to share the Jupyter Notebooks that you develop either locally or in the data science virtual machine. All right. So the next thing I want to do is scale things up from a single virtual machine into clusters of virtual machine. And there's a really nice framework that I think is not particularly well known within Azure for doing that, and that's Azure Batch. I think Azure Batch is a terrible name. It should have been Azure Cluster Computing or Azure Job Management, because what Azure Batch is all about is taking a pool of virtual machines from tens to thousands of machines and using those pools of machines to consume jobs that you pass in them or that multiple people could be passing into them at the same time. You can even set things up so that pool will scale and contract as needed according to the number of jobs that have been set up in the queue for that particular pool at any one time. And you can use any of the virtual machine types that I've been talking about to populate the nodes within that pool as well. There's quite a detailed framework behind this. There's things like tasks, which is a unit of execution, and then there's jobs, which is a collection of tasks, which will then get farmed out to the nodes in the pool. One of the really nice things is that if any of the nodes in an Azure Batch pool happens to die, or the machine crashes, or your code terminates or whatever, it'll just recognize that, hey, that job didn't work, and it'll farm it out to one of the remaining nodes, so you're guaranteed to get a conclusion to your computations. Also, one of the really nice things about using Azure Batch is cost savings for doing big and repeated compute jobs. I've already mentioned how you can scale clusters up and down as needed, but what I didn't mention already is that you can save costs by dedicating one or all of those nodes as being low priority virtual machines. Now, a low priority virtual machine is one that Azure will just take away from you at any time to serve a higher paying customer. But the benefit of using one of those low priority nodes is they cost about 20% of a regular virtual machine. And it doesn't happen very often. And when you're using Azure Batch, because of this job scheduling framework that's built around it, if one of those machines disappears, your job will just be rescheduled to one of those other machines. So you won't notice things, except that things might take a little bit longer than they might do otherwise. But it's just a lot cheaper. Another way it's a lot cheaper is that the VMs are charged for by the second. So as the pool scales up and scales down, or if you shut it down, you only pay for the time you use for those virtual machines. All right. So the process that we're going to demonstrate here is developing an application, in this case using Python, in your local environment. You'll have files, script files. You'll typically have data files as well that you will store in Azure, in this case in Azure File Store. And then you'll write a script using the Azure CLI that interfaces with the Batch AI to set up the cluster and then set up all the jobs running against those scripts and files that will then run within the Azure Batch AI cluster. And then the results ultimately will be stored in File Store and it will signal to you at the end of the day. So you'll have, for example, a trained AI model distributed over a bunch of nodes within a cluster available to you in the File Store at the end of the day. And I'm going to show you how to do that in a moment. This particular example is going to be using TensorFlow once again to train the MNIST data. The process is going to be, first of all, we need to set up storage. And again, I'm going to use the Azure CLI to do that. First of all, I'm going to create, there we go, there's my cursor. First of all, I'm going to create an Azure Batch cluster with AZ group create. Then I'm going to create the storage account here, and then populate that storage account with some files that we're going to use for the analysis in just a moment. All of this code is available in a link that I'll give you in just a moment as well. Now that we've set up the Batch AI cluster, and we've set up the storage network, we can actually do the real work. And this is where we interface with the Azure Batch API. So first of all, I've got this file that I'm going to show you in a moment called convolutional.py, and that's what Python is going to run to do the MNIST analysis. For those of you that are not familiar with the MNIST analysis, I have a bunch of handwritten digits, 0 through 9. You saw them in one of the keynotes this morning. I want to write a neural network model that's going to identify for any new handwritten digit, whether it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, based on the data that's already provided. And this convolutional.py script uses TensorFlow and the MNIST data to do exactly that analysis. So once I have that file loaded up into Azure Storage, I can then create the cluster. The important things to note about this cluster is, first of all, that I give it a name. It's excitingly called NC6, and the reason I called it NC6 is because it's going to be a cluster of the standard NC6 Azure instance. And if you remember from the slide way back when, that is a GPU-enabled instance with 8 virtual cores. For this first example, I'm just going to make the cluster of size 1. And when you define a cluster within Azure Batch, you specify a minimum size and a maximum size, which defines the limits for how you can scale it up and down. In this case, I want it to always be a single node cluster, so I'm doing a minimum 1 and a maximum 1. I'm going to mount the Azure file storage, so it's available just as an ordinary files to the Python script. So from Python's point of view, it's connected to Azure File Store, but it just sees files that it's going to be using when it does the analysis. And the rest of it is various stuff to do the authentication to connect into that file store. Lastly, and this is the one I'm going to demo right here, we're going to create a job. And that job is going to be running the Python script using Python within those clusters. But I don't submit it directly to the virtual machine. I submit it to the Azure Batch queue, and then it submits it to the machine that's available in the cluster for it to do. And all of that is specified in a file called job.json. So let's go ahead and have a look at this. I'm going to return to Visual Studio Code here. So this is the file that I'm going to send over to, actually, this is the file. There we go. Convolutional.py. This is just the standard demo file that comes with TensorFlow for doing the MNIST analysis. You're probably familiar with it if you've run any of the TensorFlow tutorials. I chose that one just to be familiar for you. The next step, some of these things I've already done, because it does take a few minutes to set up the cluster the first time, but these are the same commands that I showed you earlier on of setting up the Azure cluster. By the way, something you might have seen just a second ago, a little tooltip popped up there. This is something that's specific to Visual Studio Code. I'm using the Azure CLI extension, which gives me IntelliSense and tooltips as I'm going through and using the Azure CLI. It's very useful for programming against it. The next thing I did was to create the cluster and then create the job. So let's run this particular one over here. I'm going to go to the end of that line. There we go. And there's a keystroke that will actually let me send it straight over to the shell. AZ batch AI job create. So that's off sending that particular Python activation over to the job queue, and it will run it in just a moment. But let's actually have a look what's happening when we have a look at the Azure portal. I'm going to go back to my home, and you can see NC6 is my Azure batch cluster right here. You can go into that seat, and you can see we've got one node. It looks to be idle, which means things are probably finished already. I was talking too slowly. Let's go and have a look at our jobs. These are all the jobs that have been submitted into the Azure Batch AI. Actually, the one we're looking at is just being queued. So it's obviously waiting to activate and go in there. In a minute, that'll change from queued to running. There you go. You can see that the job scheduler has picked up that new job, found an idle node within the cluster to do the analysis, and it's gone off to that cluster. And if we have a look back at the overview, I'm pretty sure now we can see that it's actually running. It's doing the TensorFlow calculation right now. let's go back to our jobs. The one I just submitted, by the way, is TensorFlow 2. I did TensorFlow as exactly the same job a little while ago. One of the nice things about the jobs is it does store all of the output that came from those jobs, and you can just jump in and check those out. So like Julia Childs, I'm going to go back to one I did earlier here, and you can see that this one completed a couple of days ago. It ran in 4 minutes and 23 seconds, and as a result, we got the execution log, the standard error, and the standard output. I'm just going to dive in here just to show you the standard output, where you can see the process of TensorFlow training this MNIST digit recognition model, and as it goes through that process, it eventually gets down to, I think, a 99% accuracy rate of classifying digits in this training set. Now, of course, this isn't typically the way we would interface with this. We wouldn't go in and manually look at the output log, but that convolutional.py script is actually saving the output as an ONNX file directly in the file store. I shouldn't be drinking carbonated water for these demos, as I've just learned. And we would grab that from the Azure file store to then implement in the later part of our application development, as you would normally. So that's doing GPU training. We just did that demo. That was GPU TensorFlow with Batch AI. I did want to show you how you would scale that up to multi-node clusters. I'm not going to do it right now because it takes a while. I don't have data that's really big enough to make this worthwhile. You'd be surprised how much power there is in, say, a cluster of 8 NC6 VMs. But the process is pretty much exactly the same. The only difference is when I generate the cluster this time, I specify a different size, in this case a minimum of 4 or a maximum of 4 for an n-node cluster. And there's a little bit of extra cruft that I need to do to mount the data as well on every node. The way that script was set up in the one node case, it actually downloads the data from the web. I don't want to do that for all of my nodes because then things are going to get really slow. So rather, in this script, we show you actually how to put the data on the Azure file store and make it available to every node in that case. And there's just a little bit of extra work to configure Python and TensorFlow for the distributed GPU case. But in this case, it's actually going to distribute those optimizations across all the nodes within the cluster and return the results back to you just as you saw before. If you want to see exactly how that's done, you can find the recipe for that multi-node GPU TensorFlow optimization at the link you can see on the screen there, as well as lots of other examples which are really useful to check out as well. All right, and just in the last couple of minutes I got left, I want to show you a little bit about distributed machine learning with Spark. Spark is a distributed data processing engine. It's really useful in situations where you have lots and lots of quite messy data. It's easy to put fairly unstructured files into Spark and then make them appear in a structured way through the Spark API. Now, not many people work directly with the Spark API. Most people work with a language like Python or R to interface with Spark and use familiar language techniques to operate on the data that lives in there. I'm going to skip over a couple of these slides just for the sake of time. If you want to set up Spark within Azure, you actually have a couple of managed options right now. Azure Databricks was released just this year, which is a managed service for Spark. There's also HD Insights, which is Azure's data warehousing service, which is also based around the Spark API. But if you just want to set up a completely vanilla open source Spark, there is a nice tool that's available to you to do that called AZTK. You can download it from GitHub, and it provides commands very similar to the Azure CLI, just like I showed you earlier on, but with the specific job of provisioning a Spark cluster and then interfacing into that Spark cluster to do machine learning. I like to use SparklyR, which is a package for R for interfacing in with Spark, and I'll show you some examples of using that just in a minute. So the way it works is we use a command called AZTK, very similar to the AZ commands we saw earlier on to create a cluster. We connect to the Spark cluster with SSH, and that actually maps the ports from my local laptop out to the appropriate services that are running in Spark, so I can then run Jupyter Labs or RStudio just as we saw before. And again, in the interest of time, I won't jump into that right now, just maybe I'll skip right ahead and just show you some outputs. We can do things like, within that RStudio environment we just saw, we can run R code, which is interfacing with data sets that are sitting not, in this case, on my local machine, nor in a single virtual machine instance. You can interface with data that's actually living in the Spark environment, but it looks just like regular R objects, and we can interface in with the Spark ML algorithms like the linear regression algorithms, the boosted trees algorithms, all available to you within our environment without the traditionalist restrictions that you have in R and Python on the sizes of data that you can accommodate in a single node environment. So that's it. If you haven't yet got started with Azure, this is a great time to get into it, because if you follow that link right there, you can get $200 in free credits to start working with Azure. But for everybody, even if you've already signed up with Azure, there's lots of free services that are always free. Azure Batch, which I showed you today, is always free to actually create and manage clusters. You only pay for the underlying virtual machines for the time that they're in use. I showed you Azure Notebooks. That's free for the moment, at least, while it's in preview. You can also get access to things like Azure Machine Learning and the Cognitive Services APIs that are used for that Not Hot Dog application through that service as well. So thank you, everybody, and all the links that you need are right there. Have a good day.